Alright, so I'm going to keep going with definite integration. We've got some minor new stuff today, although most of it will be review. So objectives are to determine the area that's bounded by the curve from A to B, determine the integral of piecewise functions, which is new, of absolute value functions, which is also new, and then area between two curves, which we did a while ago. Okay, so from earlier, a definite integral is any integral that has bounds. So if I wanted to integrate f prime x from a to b, I would integrate by undoing the derivative. So it'll get back to the original function, then I'll plug in my upper bound and subtract my lower bound. Slower. Okay, so I'll try one. Okay, so for this one, if I wanted to integrate, I'm going to integrate every term individually and then plug in my upper bound minus my lower bounds. This is the integral from -1 to 2 of x to the 5th minus 4x cubed plus 5x minus 3. If I wanted to integrate this, what's going to happen? Okay, let's see who I've got. I've got Eileen, Jenna, and Tommy, and Sarah. Okay, so let's go Jenna. What's going to happen if I integrate this first?
X to the 6th power over 6.
Okay. X to the 6 over 6. Let's keep going. We'll finish off all these terms.
Minus x4 plus 5 over 2 x squared minus 3x.
Perfect. And we're going to do that from -1 to 2. So that means I'm going to plug in my upper bound and then subtract my lower bound. So this would be 2 to the 6th power over 6 minus 2 to the 4th power plus 5 over 2 times 2 squared minus 3 times 2 minus what happens when I plug in -1. Okay, so we'll do this really quick. I've got 2 to the 6th power over 6. 6 is 2 times 3, so that'll cancel one of these 2's. So I've got 2 to the 5th power is 32 thirds. Minus 2 to the 4th power is 16. Plus 10 minus 6 minus all of this. I've got 1/6 minus 1 plus 5 over 2 plus 3. So let's go make everything over 6, I guess. So 64/6 minus speed. Oops. Didn't do that right, did I? Okay, I've got a -1 and a 3, so that'll be 2. And then my 5 over 2, so that's 15 over 6 and 2, or 12 over 6. Okay, so if I add these together, I've got 64 plus 60, so that's 124 over 6. I've got a -96 and a -36. So that's negative 102, 132 minus 132 over 6. And then on this side, I've got a negative, that's 1628 over 6. Okay, I'm going to combine my negatives. That's negative 132 minus 28 is negative 140 minus 20 is negative 160. So I've got 124 over 6 minus 160 over 6 is negative 36 over 6 is negative 6. And we match. Okay, new stuff. If I want to integrate a piecewise function, then I'd have to treat each piece like a separate integral. So a piecewise function is a function that we define in parts. So like this. So as long as x is less than b, I'll use the top function g. If it's greater than or equal to b, then I'll use the bottom function h. So instead of just integrating f of x from a to c, I would have to split this up. To say f of x from a to b is really g of x, I'll integrate g of x from a to b, and then f of x from b to c is really h of x. So I'd integrate from b to c of h of x. Okay, so here's one example, and then we'll do another one together in a minute. Okay, that's an absolute value, so I'll come back to that one. So I've got a piecewise function here, defined in 2 parts. Whenever we are less than or equal to -1, I'm going to use the top part. If we are greater than -1, I'll use the bottom part. So if I wanted to integrate from -2 to 5 of f of x, that would be the same thing as integrating from -2 to -1 of the top function. And then because integration, again, is repeated addition, I can add another integral from -1 to the end of my interval at 5. It will be greater than -1 for all of that, so I'll be using the bottom function, x minus 1 dx. Okay, any questions on the first step? Okay, I'm going to jump to somebody else. So let's see if I've got all the chats. We just did Jenna. Next on my list is Aileen. So what's going to happen when I integrate our first integral here?
X squared.
Okay, negative x squared. Okay, I've got one more term for that integral. So this should be negative x squared minus
4x negative.
4x, perfect. That one's going from -2 to -1. Okay, and then I'm adding this second integral. So next on my list is Kenichi. Kenichi, what's going to happen when I integrate this one? Okay, first term you said was x to what power?
So x negative 1, right?
For this one we're integrating, so I'm going to add 1 to the power and divide by the new power. Okay, so you can see on the left, negative 2 became, or negative 2x became, I added 1 to the power, so instead of x to the first power, this became x to the second power, and then I divided
Mm-hmm.
by 2. So for this one over here,
So it's gonna be x to the power of 2
okay, over,
over, wait,
okay, add 1 to the power, we did that, and then divide by the new power.
mm-hmm.
Okay, divide by 2.
Yeah, okay.
And then this is 1, which is x to the 0 power, so what's going to happen here?
1.
Okay, so this will be x to the first power over 1.
Mm-hmm.
Okay, I'm going from negative 1 to 5. Awesome. Okay, then next I've got Tommy. Have you help me out with just the adding really quick after I get this in? So I'm going to do my upper bound and subtract my lower bound. Oops. Okay. Let's go ahead and do this, I guess. So I've got just distributing my negatives. This is 1 plus 4. If I distribute in here, I've got a negative. This one will square to become positive, and then I got the negative that I distributed in here, so this is positive 4. I've got a negative times a negative times the negative is positive, so plus 8. Plus 25 over 2. Um, added 8. Okay, should be negative because I distributed that twice. Okay, cool. That was good. So I've got 1 plus 4 is 5. 25 over 2 minus 1 over 2 is 24 over 2 is 12. So I've got 4 minus 8 plus 12. Sixteen minus 8, I've got 8. Okay, I've got something wrong here, so I need to keep going. 1, 4. That's fine. Squared minus 5. Okay. Oops. Okay, that's 3 over 2. Should be 22 over 2 is 11. Okay, I've still got something wrong, so somebody help me out. So seeing where we went wrong. That's good. Lower bounds.
Mr. Brandon,
Yes.
I think you forgot the squared for -1, the first term.
Okay, let's see for that. -1 here. I did. Okay, thank you. Okay. All right, so my 5s don't cancel. I'm left with an extra -2 here then. Okay, awesome. Thank you very much. Okay, and the last one, if I want to integrate with absolute values, what I'm going to do is I'm going to try to figure out whenever that absolute value would be negative. And then we'll have to make that section of the integral positive before we integrate. Here's what it'll look like. So for this example here, I'm going to take this x squared minus 3x and set that equal to 0, and then solve for x. So we're going to hit 0 at 0 and 3, and then we'll split that up into our interval. So this is going to be, if I test around 0 and 3, if I plug in any number that is less than 0 into x squared minus 3x, I'll get a positive number. Between 0 and 3, I'll get a negative number, and then after 3, I'll get a positive number, which means this interval is positive first. So if I wanted to integrate our original function from -1 to 4, my first interval from -1 to 0 will already be positive. So if I take away the absolute value signs, I can leave this as is, and I'll still be positive before I integrate. Okay, for my next one though, from 0 to 3, that interval will be negative. So if I take that negative interval and I multiply by -1, I'll change that and make it positive. So what this -1 is doing is basically our absolute value. That's taking the negative part of the interval and making it positive. Okay, and then this from 3 to 4 is above 3, which we said would already be positive, so I don't need to multiply by -1 for this one, since that interval is already positive. Okay, then everything else is exactly the same as last time, where I integrate, adding 1 to the power and dividing by the new power for each term. And then plug in upper bound and subtract lower bound in order to get my answer. Any questions on this one? Okay, then I'm going to try one more live. Okay, so we are integrating from 1 to 7 of -x plus an absolute value. So I'm going to split that absolute value out of our fraction. So outside of this integral for the first part. Okay, so this is my first integral. I've just pulled that out. Because integration is repeated addition, anytime we're just adding, I can split that up into a separate integral. So I've got a separate integral now from 1 to 7 of everything that is within that absolute value, which is -2x plus 4 dx. Okay, then I'm going to take a look at this -2x plus 4 and try to figure out when it would be negative. So -2x plus 4 is equal to 0. Whenever x is 2, and I'm going to split around that into my original function. If I plugged in a negative number right now, this would be negative. If I plugged in a, plug in a negative number right now, this will be positive. If I plug in a positive number right now above 2, this will be negative. So I'm going to split this interval around 2. Okay, I've got my first integral from 1 to 7 of -x dx. Doesn't have an absolute value, so that part doesn't need to change. This part does. So my integral from 1 to 2 is already positive, and we don't need to do anything to it. Negative 2x plus 4dx. But my integral from 2 to 7 would be negative, so I'm going to multiply by an extra negative 1 in order to make that positive. And that'll be doing the same thing as what the absolute value signs would have done. And then we're good to go. Okay, any questions on our initial setup? Okay, and the rest of this should be the same. So if I integrate this, what did I have next? I had Tommy next. Tommy, if I integrate this first one, what's going to happen?
X negative. Oh my god.
Okay, I'm going to add 1 to the power, divide by the new power.
Negative. Wait. Negative 2.
Okay, so this was a 1. So if I add 1 to the power, this would be a positive 2. Okay, then divide by
2.
2. Okay.
7. 2.
Okay, so dividing by 2, then I'm integrating from 1 to 7. Okay, cool. And then I'm going to add my integral of this term. So I'm going to jump over to Sarah. What will happen if I integrate this middle term?
Negative 2x to the second power divided plus 4x.
Okay. And I'm going to put that one from 1 to 2. Okay, and then I'll do the same thing over here. Minus 1 times from 2 to 7. Okay, I just need to plug in upper bound minus lower bound, then we should be good to go. So this is, this negative is on the outside of our x squared, so that's going to stay negative. So this is negative 49 over 2 plus 1/2. Plus, if I plug in 2 here, this will be okay, I'm going to get rid of these 2's. There we go. Okay, so this is negative 4 plus 8 minus 1 plus 4. Okay, and then we can add straight across. So this is going to be negative 24. I've got 4 minus 3. And okay, so I've got 25 minus 24 is 1 plus 1 is 2. . Okay, any questions on what we did here? Okay. Last one, if I want the area between two curves, I'm going to integrate from the top function to the bottom function. So that's everything under the top minus everything on bottom. So if I wanted to integrate from here, x equals a to here, x equals b. If I integrate everything underneath the top function, I'll get all of this space in yellow. And then subtract everything here underneath the bottom function in blue. It is not quite working out how I hoped. There we go. Okay, and then all of the yellow and blue will combine to make green. I'm going to get rid of all of the green stuff when I subtract that bottom area, and I'll be left with just this yellow area in the middle. Okay, so for something like this, which function is on top? Let's see if I can get Zoom to work. So, Kelly, which function is on top? Okay, I've got nothing from her, unfortunately. Try one more time. Alright, I had no luck there, unfortunately. So, sorry, Kelly, I can see you speaking, but I can't hear you. So, everyone's unmuted. Nope. Okay. So my top function here is 2 cosecant squared x. So I'm going to integrate our top function 2 cosecant squared x minus our bottom function, so that's minus negative cosine x, or plus cosine x dx. And I'm going to go from our leftmost, which is negative 3 pi fourths, to our uppermost, which is negative pi fourths. Okay, so back to the top of the order then, so that's Jenna. What happens if I integrate 2 cosecant squared x?
Negative 2 cotangent x.
Okay, that's perfect. And then hello.
Hello.
And then Aileen.
Sorry.
That's okay. So Aileen, if I integrate cosine, what's going to happen?
Negative sign.
If I derive negative sine, I would get negative cosine.
Yeah.
I'm looking for what function could I derive in order to get cosine?
Sign.
Sine, there we go. So this is plus the sine of x. Okay, and then we're going from our lower bound 3 pi fourths to our upper bound of negative pi fourths. Okay, so we'll plug that in. This is negative 2 cotangent at negative pi fourths plus the sine at negative pi fourths minus negative 2 cotangent at negative 3 pi fourths plus sine at 3 pi fourths. Okay. Anyone, what is the cotangent at negative pi fourths? Okay, that's an odd number times pi over 4, so that means my side lengths are equal. So this is root 2 over 2, and this is also root 2 over 2 for my unit circle. But my y value will be negative if I'm going down. Okay, so my cotangent, which is x over y, will be root 2 over 2 divided by negative root 2 over 2. So this will be negative 1. My sine at negative pi fourths was that y value, which was negative root 2 over 2. Okay, then I'm going to subtract. Our cotangent at negative 3 pi fourths. So instead of going 1 pi fourth, I'm going to go backwards by 3 pi fourths. If you don't like that, I can always add 2 pi, which is 8 pi fourths, to this angle and get a positive angle that would be on the unit circle. If I do that, that would be 5 pi fourths. So 5 pi fourths going positive will end up at the same angle. Okay, at that angle, we are an odd number times pi fourths, so I'm still root 2 over 2 for both of my magnitudes. But this time, both my x and y are negative. So this would be negative root 2 over 2 divided by negative root 2 over 2 is positive 1. And then my sine is negative root 2 over 2. Okay, and then we can add straight across. So this is 2 minus root 2 over 2 plus 2 plus root 2 over 2. Or 4 units total.